Good morning to all of you. I welcomes to all in our lecture series on probability statistics. In our last class, we have been discussed in detail about proof of Chebyshevs inequality. We proved these two statements that probability of x minus mu mod greater than equal to k sigma will be less than equal to 1 by k square, or x minus mu mod less than k sigma will be equal to greater than equal to 1 minus 1 by k square, where k is your positive real value, mu is the mean, sigma is the standard deviation of any distribution that may be discrete or that may be continuous. Here one thing you have to remember, that this inequality or theorem uh, will be give us not exact value of the probability. It will give the uh, approximate value of the probability of a range. That means, suppose we have the mean at this point of a distribution that may be discrete, distribution, or that may be continuous distribution. Suppose this is my mean and I have the standard deviation sigma. Then by applying Chebyshevs inequality, I can found the probability. Either suppose this is the range of kv. Suppose this is your mu plus kv, this point, and this point is your mu minus kv, where k is a positive real. Then by using Chebyshevs inequality, we can estimate approximate probability either in between this range or beyond this range. Okay, so in this video we are going to be solve 5 to 6 numericals using this inequality. Okay, so this is our first question. So this is the first question, that suppose a random variable x has a mean is 8 and variance is 9 and an unknown probability distribution. Find probability in between -4 to 20 and probability x minus 8 mod greater than equal to 6. What will the value of this one and this one? We are going to find out by using Chebyshevs inequality. So here solution starts, and given the data, mean equal to mu equal to 8 and variance, that is your sigma square, equal to 9. So hence this is your standard deviation equal to 3. Okay, first we are going to consider this probability. Okay, now we are going to find out probability of -4 in between -4 to 20. We know, according to Chebyshevs inequality, probability of x minus mu less than k sigma is greater than equal to 1 minus 1 by k square. Let this is your equation number 1. Okay, now consider this one, probability of -4 uh, less than x, which is x is less than 20. Now we have to subtract 8 from this and this. So -4 minus 8, x minus 8, 20 minus 8, it will be -12, which is less than x minus 8 less than plus 12. So this range can be written as x minus 8 mod less than 12. Already we have been discussed in our last class. Okay, let this is your equation number 2. Now compare equation number 1 and 2. Here we can get this 8 is belongs to mean, and here mu is also mean, and sigma is the standard deviation, k is any positive real quantity. So here k sigma equal to 12. So hence sigma already given in the question, that 3. So that implies k will be equal to 4. Now using equation number 1 and 2, probability of x minus 8 mod less than 12, which will be equal to greater than equal to 1 minus 1 by k square. 1 minus 1 by k we found 4, so it will be 1 minus 1 by 16. So this probability will be greater than equal to 15 by 16. As I told, that by using this inequality or theorem, we can get the approximate value of the probability. Here we found the approximate value of the probability is your 15 by 16. Now we are going to go for to find out this probability, that is your probability of x minus 8 greater than 6. Now consider this one and let this is your equation number 3. Consider another form of Chebyshevs inequality, that is your probability of x minus mu greater than equal to k sigma, which will be less than equal to 1 by k square. That we know, that we have been proved itself in our last class. Okay. This one. Okay. So now we have to compare equation number 3 and 4. This is your equation number 3 and this is your equation number 4. You just compare. We can found k sigma is your 6. Sigma already given than 3. So hence k will be 2. So hence the probability of this one will be less than equal to 1 by 2 square will be 1 by 4. Right? See, here I solved this problem with step by step. But in your exam you can reduce the step. Okay. Now another question is that, second question, our random variable x has a mean given that mu equal to your 12 and variance 9 and has unknown probability distribution. Find probability of 6 which is less than x less than 18 and probability 3 less than x less than 21. See, as I told that this Chebyshevs inequality can be applied for unknown probability distribution and also a known probability distribution. How? For the known probability distribution, I done 2 questions. Here we are going to discuss. So here this question is belongs to unknown probability distribution. That probability distribution we don't know, but however we can found the approximate value of the probability by using this inequality. So now we have to go for the solution. Mu is given that 12, that is your mean. Sigma square, the variance is 9, hence standard deviation equal to 3. Root over of this one 3. Consider this one, 6 less than x less than 18. Let this is your equation number 1. Now we are going to consider Chebyshevs inequality, that is your x minus mu less than sigma, which will be greater than 1 minus greater than equal to 1 minus 1 by k square. Let this is your equation number 1. Now we are going to compare 1 and 2. So before we are going to compare, see, we have to do something with equation number 1, that here this is x minus mean. So here also we are going to be consider that same thing. X minus mean is your 12. So x minus mean means left hand side also this we are going to consider 6 minus 12, and this term 18 also going to be subtracted by 12. So 6 minus 12 less than equal to x minus 12 less than equal to 18 minus 12. With each term I subtracted 12. So here this will be minus 6. This will be x minus 12 less than that of the 6. So this range can be written as x minus 12 less than 6. Let this is your equation number 3. Now you just compare this equation and this equation 3 and 2. We found that this 6 is nothing but your k sigma. So that implies if 6 will be equal to k sigma, hence k will be equal to 2. Therefore the probability of this one, or you can say this one or this one, will be equal to greater than equal to 1 minus 1 by k square. K is your 2, so 1 by 4. That is your 1 by 4. 1 minus 1 by 4 will be 3 by 4. So hence the probability, required probability of this one will be greater than equal to 3 by 4. Not exactly given, it will be given the approximate value, that is your 3 by 6. Now we are going to go for this one, 3 less than x less than 21. Similar way we are going to subtract minus 12 from each of the term. So 3 minus 12, x minus 12, 21 minus 12, that I am going to be equivalent with Chebyshevs inequality. Okay, so here we found minus 9, x minus 12 less than 9, or we can write this range will be equal to probability of x minus 12 less than 9. Let this is your equation number 4. Now you just compare this one with equation number 2, this one. So here 9 will be equal to k sigma. See here x minus mean is there, here also x minus mean is there. Less than 9, here less than k sigma. So here k sigma will be equal to 9, so k will be 3. So that implies probability of x minus 12 less than 9, or probability of 3 less than x less than 21 will be 1 minus 1 by 9 will be equal to 8 by 9. Next we are going to go for the next question. Question number 3. This is another interesting question, that does there exist a variable or a random variable, you can write, x, for which probability of this much mu minus 2 sigma less than equal to x less than equal to mu plus 2 sigma will be equal to 0.5. We are going to check. So given that this one, probability of mu minus 2 sigma less than equal to x less than equal to mu plus 2 sigma, here mu equal to mean and sigma is your standard deviation. So the equation can be written, this one can be written as, here I am going to subtract from each term the mean mu. So here if I will subtract mu, it will be minus 2 sigma less than equal to x minus mu less than equal to 2 sigma. So this range can be written as x minus mu less than equal to 2 sigma. Let this is your equation number 1. Now we have to consider the Chebyshevs inequality as this one, x minus mu less than equal to k sigma, which will be equal to greater than equal to 1 minus 1 by k square. Let this is your equation number 2. Just compare 1 and 2. We found that here you can see that if I am going to compare equation number 1 and 2, so probability of x minus mu less than equal to k sigma, which will be greater than equal to 1 minus 1 by 4, which will be equal to greater than equal to 1 minus 1 by 4, or the value is 3 by 4. Or we can write probability of x minus mu, this is not k sigma, this is your 2 sigma, okay, because here 2 sigma means I have to write 2 sigma, right? If I am going comparing equation of 1 and 2, k will be 2, right? So 2 sigma will be greater than equal to 0.75, but in the question it is given that equal to 0.5, but actually by using this inequality, Chebyshevs inequality, we found that it has to be greater than 0.75. So since 0.75 not to be equal to 0.5, say hence there does not exist such random variable x for which probability will be equal to 0.5. Fourth question is that, suppose number of items produced by a company in one day is considered as a random variable x. Whatever the company is producing its product in one day, suppose that is your random variable x. The mean of the production, given that 50, and the variance, if the variance of the production in a day is equal to 25, then what is the probability that can be said that the productivity will be between 40 to 60? So this question you have to do by yourself. This is what you have to do. I am going to give the hints. You can see here already given the mean equal to your 50 and variance is your sigma square equal to 25. That means standard deviation given 20. Sorry, standard deviation will be 5. Okay, standard deviation will be 5. So we have to find out that the probability in between 40 to 60. So we need to find out probability in between 40 to 60. So 40 less than x less than 6. So what you want to do, that 40 minus the mean will be 50, again x minus 50 less than 60 minus 50. So after doing this, you just equivalent with this one with the Chebyshevs inequality of this one. So by considering inequality Chebyshevs inequality this one and comparing this one with this value, you can found the k value, and using that k value you can found the probability of this one will be 3 by 4. You just do it by yourself. Okay, next question we have to move. Question number 5. Here it is given that if x is a uniform distributed over the interval 0 to 10, then apply Chebyshevs inequality to find the bound on probability. This question asked in your Utkal University exam in 2019. So just watch how we are going to solve it. See, here it is given that uniformly distributed. Here previously whatever the question we have been uh, done now, their unknown probabilities distribution. Here given that uniformly distributed. So uniformly distributed means like this. So 0 to 10, this is the distribution. Okay, uniformly distributed. So if you want to know about the uniform distribution, already I have been uploaded. You can check the playlist of this probability statistics. You can found about uniform distribution, and for the uniform distribution, uh, the mean is your a plus b by 2. That means the lower and higher limits value you have to add divided by 2. That is your mean, and variance is your b minus a square by 12. So here these two values we are going to use to solve this problem. So given that x is distributed uniformly in the interval 0 to 10, so this is the figure, and so uniformly distribution for uniform distribution, mean mu equal to a plus b by 2, that is your 0 plus 10 by 2 equal to 5. Variance, that is your sigma square equal to b minus a square by 12, 10 minus 0 square by 12 equal to 100 by 12, and standard deviation will be root over this one. Approximately you can found 2.88. Here we have to find out bound on probability. That means suppose we are going to consider x is greater than beyond the 10. Okay, x is greater than 10. That means or we can consider, if I am going to subtract minus 5 and minus 5 from this and this, x and 10, we can found probability of x minus 5 greater than 10 minus 5, or probability of x minus 5 greater than equal to 5. Let this is your equation number 1. And as we know that this range is nothing but x less than 0 and x greater than 10. That means probability of x less than 0 union of probability of uh, x x greater than 10, x greater than equal to 10. So now we have to apply the Chebyshevs inequality. According to Chebyshevs inequality, probability of, here I forgot to write, probability of x minus mu greater than equal to k sigma will be less than equal to 1 by k square. Okay, this one, right? These things we are going to use now. So probability of x minus 5, instead of mu I can write 5 greater than equal to k sigma. So here instead of k sigma we have 5 value less than equal to 1 by k square, it has to be. So now we are going to be compare equation number 2 and 1. Actually this has to be, okay, no problem. Now you have to compare this one, equation number 2 and 1. Here you can found that sigma k, this is, you just write, this one is your mu, this one is your equation number 2. Okay, this one is your equation number 2. It will better. So by comparing equation number 1 and 2, we found that here 5 equal to k sigma. 5 equal to k sigma. K will be equal to 5 by sigma. Already we found 2.88. 5 by 2.88 will be 1.76. So hence probability of x minus 5 greater than equal to 5 will be less than equal to 1 by uh, 1 by k square. Here less than equal to 1 by k square, it will be 1 by 1.736 square will be approximately less than equal to 0.33. But actually probability for this case will be 0, because beyond this there is no PMF uh, is present. So PMF, probability mass function, present in between 0 to 10. So if I am trying to find out the probability in this range and this range, we are going to find out the probability will be 0. So actual probability will be 0, and by Chebyshevs inequality, applying Chebyshevs inequality, we found in that range this will be less than that of the 0.33. Okay, given this value, given the approximate value of the probability. Now we are going to go for another question, that a random variable x has the density function e to the power minus x, which is where x, for x greater than equal to 0, find the upper limit of probability of x minus 1 greater than 2. So given PMF is e to the power minus x for x greater than equal to 0 and 0 elsewhere. This is a exponential distribution. See, if we are going to consider the exponential distribution, you can check my the playlist of this probability statistics. You can found I uploaded also about exponential distribution. I am going to show you. Wait. So you can see that for exponential distribution, that is your theta into e to the minus theta x. For this case, we have the expectation of x or mean equal to 1 by theta, and variance is your 1 by theta square. Okay, you can check about this distribution, whatever I have been uploaded in detail previously. Okay, so here if I am going to consider exponential distribution, that is your theta into e to the minus minus theta x, where x greater than equal to 0, 0 elsewhere. Here theta, if I am going to compare this distribution with this one, so theta equal to 1. So hence mu, as we saw that mu equal to 1 by theta equal to 1, and variance is your 1 by theta square, that is also 1. Or standard deviation will be equal to root over of 1 will be 1. And either way also we can found the mean and variance of this distribution, whatever given in the question, that is your 0 to infinity x into e to the minus x. This is a gamma distribution, gamma function, that is e to the x minus x, x to the power 2 minus 1 is your gamma 2 equal to 1. Or expectation of x square will be equal to 0 to infinity x square into e to the minus x dx, or e to the minus x into x square into dx, that e to the minus x into x to the power 3 minus 1 dx. Gamma will be equal to gamma 3 will be 2 factorial will be equal to 2. So variance will be ex square minus ex whole square, 2 minus 1 equal to 1. So hence standard deviation we found 1. Either you can consider by comparing exponential distribution with given distribution, or give from the given distribution directly you can found the mean value and the variance value, and obviously standard deviation will be 1. Now we are going to go for the finding this value whatever given in the question, that is your probability of x minus 1 greater than equal to greater than 2. Let this is your equation number 1. Here this range is nothing but probability of x less than that is mu less than mu minus 1, because as we know by considering uh, Chebyshevs theorem, not Chebyshevs theorem, as we know that this range is nothing but will be x less than mu minus this one, 1 minus 2 will be equal to minus 1, and union of x mu plus this one greater than 3, x greater than 3, this is union. Okay, so now consider Chebyshevs inequality, that is your probability of x minus mu greater than k sigma, which will be less than equal to 1 by k square. Let this is your equation number 2 and just compare this one with this one. We found k sigma will be equal to 2, where k equal to uh, 2 because sigma will be 1. So hence probability of x minus mu greater than k sigma will be less than equal to 1 by 2 square, or instead of mu we can write 1, and here this will be equal to 2 already here. It is given in the question. So probability of x minus 1 mod greater than 2 will be equal to, will be less than equal to 1 by 4, not given exact probability but given the approximate value, which will be less than that of 1 by 4, right? Now we are going to move for the next question, that is your question number 6. A random variable x as the density function has been given e to the power minus x, where x greater than equal to 0. For x greater than equal to 0, find the upper limit of probability of x minus 1 mod greater than 2. Okay, so here is the solution. Given that the probability density function is your e to the power minus x, this is a continuous distribution function. Here given the density function e to the minus x for x greater than 0. So obviously for other value of x, this function PDF will be 0 elsewhere. This is a exponential distribution. This is exponential distribution. Maybe you remember already, we have been discussed in our previous class, that is for exponential distribution, probability density function is your theta into e to the minus theta x for x greater than 0, otherwise it will be 0. And this is the proof of PDF, and we found that for this case the mean is your 1 by theta and the variance is your 1 by theta square. Here theta is nothing but the coefficient of e to the power minus theta x, right? So if I am going to compare this exponential distribution with given density function, here you can see this also I have been written over here that if we consider the exponential distribution, that is your theta into e to the minus theta x, x greater than 0, elsewhere 0, here theta equal to 1. For so here that means for this case, if I am going to compare this and this and this, so theta will be equal to, here the coefficient is how much, 1, so 1. So hence mean will be 1 by theta, as we saw that 1 by theta equal to 1, and variance for exponential distribution here, that is your 1 by theta square 1. So hence standard deviation sigma will be 1. So in this way you can estimate the mean and standard deviation, or direct method you can use, that we know that the for continuous distribution expectation or mean value of x will be the range limit, that is your 0 to infinity x into PDF e to the minus x dx, and obviously this is a gamma function. So e to the minus x to the power n minus 1, here 1 is means 2 minus 1, I can write 2 minus 1 dx. So e to the minus x to the n minus 1 is nothing but gamma n will be equal to gamma 2 will be equal to 1. Similarly e x square will be 0 to infinity x square e to the minus x dx, and or e to the minus x into x to the power 3 minus 1 dx, which will be nothing but gamma 3 equal to 2 factorial equal to 2. So variance will be ex square minus ex whole square 2 minus 1 1, standard deviation 1 equal to 1. So direct method also you can use to find out mean and variance and corresponding standard deviation. Here it is asked that we have to find this one, x minus 1 mod greater than 2. So now we are going to use the Chebyshevs inequality, that is nothing but in general this one probability of x minus mu, x minus mean greater than k sigma, that is standard deviation, will be less than equal to 1 by k square. So here we have to find out this one, that means this is the range of probability of x less than minus 1 union of x greater than 3. That means if this is your mean we found 1, this is mean equal to 1, and this is your x minus 1 greater than 2 means 1 minus 2, 1 minus 2 means minus 1 here, and 1 plus 2, suppose this is a 3. So beyond of this one and beyond of this one, what will the probability, it has been asked. So consider the Chebyshevs inequality equal to this one less than equal to 1 by k square. You just compare this equation and this equation, we can find k sigma will be equal to 2. So hence k equal to 2 because sigma we found equal to 1. So hence as this value equal to less than 1 by k square, so here k equal to 2 means we can get 1 by 2 square, less than equal to 1 by 2 square, 2 square, that is your 4, 1 by 4. Hence we found probability of x minus 1 mod greater than 2 will be less than equal to 1 by 4. It is given the approximate value, not exact value. So we found 1 by 4. Next we are going to go for the next question, that for geometric distribution, here it is given geometric distribution, one discrete random variable, that is 2 to the power minus x, where x equal to 1, 2, 3. Prove that Chebyshevs inequality gives probability of x minus 2 mod less than equal to 2 will be greater than 1 by 2, while actual probability equal to your 15 by 16, right? So this is our PMF, probability mass function. So expectation of x will be considering summation over x equal to 1 to infinity x into PMF 2 to the power minus x. So x equal to 1 to infinity x by 2 to the power x. So put each value of x, it will be 1 by 2 plus 2 by 2 square plus 3 by 2 to the power 3 plus 2 4 by 2 to the power 4 and so on. So here we consider that 1 by we are going 1 by 2 taken outside means it will be 1 plus uh, 2 by 1 by 2, 3 by 1 by 2 square plus 4 by 1 by 4 by 2 to the 3. Okay, and we consider a equal to 1 by 2. See, if I am going to take 1 by 2 common from these terms, then I can get 1 by 2 into 1 plus 2 by 2 plus 3 by 2 square plus 4 by 2 cube, like this. Okay, I consider that a equal to 1 by 2. So hence this will be 1 by 2 into 1 plus 2 into 1 by 2. 1 by 2 means a plus 3 into, here you can see 1 by 2 square means a square plus 4 aq and so on. So this series can be written that 1 minus a to the power minus 1 by 2. So here a is nothing but 1 by 2, so we can get 2. So expectation value or mean we found 2, and ex square similarly you can do, and we can found half 1 plus a into 1 minus a to the power minus 3, where a equal to 1 by 2 will be equal to 6. So variance will be equal to this much minus ex square, okay, ex square, that is your 2 to the power 2 equal to 4, and we found sigma square equal to 2, sigma equal to root 2. So now we are going to use the Chebyshevs inequality, that is your probability of x minus mu is the mean, less than equal to k sigma will be greater than 1 minus 1 by k square. Let this is your equation number 1, and as it is given that we have to prove this one, x minus 2 mod less than equal to 2 greater than 1 by 2, consider probability of x minus 2 less than equal to 2. Consider this is your equation number 2 and 1, this is your 1. Compare these two, equations, we found k sigma equal to 2. So hence sigma equal to root over of 2, because k equal to root over 2, because sigma we found root 2. So hence 1 minus 1 by k square, 1 minus 1 by k square means 1 minus 1 by 2 equal to 1 by 2. So probability of x minus 2 mod less than 2 will be equal to greater than 2. Hence it has been proved. Now we are going to go for the next question, that a symmetry die is thrown 600 times. Find the lower bound for the probability of the getting 80 to 26 sixes. Okay. So here it is asked that we have to find out what will the probability that 6 we are going to get 80 to 120 times. So this is the representation of getting 6. This has been we have to find out this value, uh, lower bound for the probability of 80 to 126. Okay, so here we have to consider, let the number of successes or successes sixes will be equal to 6x. Okay, consider the so-called random variable is your successes is your x. So expectation of x will be equal to np. Why we consider this one? Because you carefully you have to watch, this is your belongs to your binomial distribution. Here we are trying to find out the corresponding six number of 6 and not 6. So success is getting 6. If I got 6, then I will be succeeded. If I not got the 6, I failure. So here success and failure have the probability of, if success will be q, the probability will be, failure will be 1 minus p equal to q. If success, if we are going to take p, the failure will be q. Okay, and p plus q equal to 1, uh, which is belongs to binomial distribution. So as we know that for binomial distribution, expectation value is your n into p, number of trials into success. So number of trials is your 600. 600 into here the success probability of success. P is belongs to probability of success, that is your 1 by 6. Okay, so here P is belongs to probability of success, and probability of failure will be 1 by P considered Q. So P plus Q, as we know that it will be 1. Okay, so if we are going to be throw a die, so it may be 1 2 3 4 5 and 6. So getting the 6, the probability will be 1 by 6, and not getting the 6 will be 1 minus 1 by 6 equal to 5, 1 by 5 by 6. So here P is considered as 1 by 6 and Q is considered as 5 by 6, right? And P plus Q will be equal to 1, 5 by 6. So here expectation of x will be n into p, 600 into 1 by 6 equal to 100, and variance will be expectation of x square minus ex square, and also we know that this is your npq for binomial distribution, right? That will be 600 into p is nothing but probability of success 1 by 6, probability of failure q is belongs to 5 by 6 equal to 500 by 6, and sigma standard deviation will be 500 by 6 root over. Now using Chebyshevs inequality, we can get that probability of x minus mu less than k sigma will be always greater than equal to 1 minus k square, 1 minus 1 by k square. Let's consider that this is your equation number 1, and this is nothing but the range of mu minus k sigma less than that of the x less than that of the mu plus k sigma, which will be greater than equal to 1 minus 1 by k square. So for this case, if we are going to consider the question, we need to find out the probability of 80 in between 80 to 20, getting success. So success, number of success 80 to 20, what will the probability? So 80 to probability of 8 less than x less than 120 will be how much? So to apply the Chebyshevs inequality, what we are going to do? We are going to subtract from 8x 120 by mean. Okay, so 80 minus 100, x minus 100, 120 minus 100. So this will be minus 20, this will be x minus 100, this will be 20. So this range is nothing but x minus 100 less than 20. So greater than 1 minus, you can write itself 1 greater than equal to 1 minus 1 by k square. uh, Let this is your equation number 2. Just compare equation number 1 and 2. Okay, compare equation number 1 and 2. You can found that k sigma will be nothing but 20. So obviously k will be equal to 20 by sigma will be nothing but sigma is nothing but 500 by 6. So it will be into so here I somewhat mistakenly written, just write 20 by 20 by sigma. Sigma is your 500 by 6. 500 by 6 root over. Okay, 500 by 6 root over, right? So hence 1 minus 1 by k square will be 1 minus 1 by k uh, mm, is your 20 by 500 by 6. So 20 by 500 by 6 whole square. Okay, 500 by 6 root over whole square. So this is 1 minus 1 by, this is 20 square equal to 400 uh, into, sorry, divided by 500 by 6. So this will be 19 by 24, right? See carefully, you have to write here that this is your k is your 20 by 500 by 6 root over. So here 1 minus 1 by k square, 1 minus 1 by, this is your 20 by, this is by root over of 500 by 6 whole square. Okay, so considering whole square, it will 1 minus 1 by 20 means 400 divided by 500 by 6. So you just solve it, you can get 19 by 24. So hence probability of in between this range getting the 6 will be greater than equal to 19 by 24 given the approximate value of the probability. Okay, so in this video we have been discussed 8 numericals. Here this one is your belongs to one discrete random variable, this one is another discrete random variable given distribution function, and here it is not given. You have to just identify belongs to which probability distribution. Okay, uh, and this is belongs to one continuous distribution. Given PDF means given range means given PDF, that is also written uniformly distributed, that means given PDF. And here is one of the different type of question. This is one another type of question. Here question number 2 and 1 belongs to unknown probability. So we just touched different types of numericals by using uh, how to solve by using Chebyshevs inequality. So I hope somewhat you have been knowledge from this video, which will be helpful for your exam. Watch carefully, write down the note, and thank you so much for watching this video. Thank you.